Okay, so let's look at some examples. So before we can really tell where the wholes, asymptotes, and zeros are going to be, we need to go ahead and factor this out. So this should be easy enough. This looks like it's x plus 6 over, and then x times x plus 1 all over x plus 3. So we've got this all factored out. Does not appear that there are any common factors between the numerator and the denominator. So first step, we say there are no wholes. Again, there's no common factor between the numerator and denominator. So the next thing we're going to look at are the vertical asymptotes. So vertical asymptotes, just gonna abbreviate that by VA. Vertical asymptotes, that's where we're looking at the denominator. So we're going to be looking at x plus 3 and seeing where x plus 3 equals 0. Well, x plus 3 equals 0 when x is negative 3. So what this means is at x equals negative 3, we've got a horizontal asymptote. So if we were going to go and draw that, oh, I drew that at positive 3. Oops. Alright, so horizontal asymptote. The next thing we're going to look at is the zeros. So this is where the graph crosses the x-axis, and we want to look at the numerator this time, so specifically x plus 6 and x plus 1. We want to know where either of these is equal to 0. So we know it's 0 here when x is negative 6 and when x is negative 1. So if we go here, we've got a 0 here at negative 6 and another 0 at negative 1. So one thing we know about the graph so far is that it crosses the x-axis at these points and it never touches our green line. And finally, we're going to be looking at the horizontal asymptotes. We're going to abbreviate that with HA. So horizontal asymptotes. This is where we specifically look at the degree. So that's the highest exponent up here in the numerator and the highest exponent in the denominator, which is just 1. If we look back at our rules, since the degree of the numerator, which is 2, is greater than the degree of the denominator, which is 1, that means there are no horizontal asymptotes. So this is basically what we know about the graph so far. So our final picture, we need to make sure it's going to pass through this point, and this is where we can kind of help get a visual on what this looks like using a graphing calculator or something. But or if you go to your table on your calculator, you'll see that the graph looks something like this. It's going to get really close to the asymptote but never touch it. So that's kind of a rough sketch of what it looks like. If you want a really precise view of what it looks like this, where you have the line at x equals 3, it's never touching it. If we were to zoom out, notice it just keeps going infinitely up and infinitely down. Okay, so let's go to our next example. So let's go down to example number 3. Okay, we're going to start by factoring this out. Looks like the numerator is just fine with x minus 2. Denominator, we can factor out an x, and then we get x times x plus 1. Alright. Third time's a charm. No wholes, because there are no common factors between the numerator and denominator. We're going to look at our vertical asymptotes. which we look at the denominator for, so we need to figure out, so one of them is where x equals 0, so we're looking at this one, and we also need to look at where this equals 0. So we've got x equals -1. So at these 2 points, they're really close together, so this will be fun. The line x equals -1 and the line x equals 0, which happens to be the y-axis. So we've got a little chunk of this graph fitting right between these two lines. Next, let's look at the zeros. Oh, I think I've been writing that in blue. So the zeros. That's where our numerator is equal to 0, so x minus 2 is 0. So we have the graph, this rational function intersects the x-axis at x equals 2. Which is kind of interesting considering that there is oh, wait a minute, spoiler alert. Okay, hold on, let's get to the last one. Let's look at the horizontal asymptotes. So that's where we're looking at degree. So we've got degree of 1 on top and degree of 2 on bottom. So 1 is less than 2, which means that we have a horizontal asymptote at y equals 0. So on our x-axis, we've got an asymptote, which is kind of mean because notice our asymptote intersects with our 0. So this asymptote is here, and a majority of time, except for at this one point, our graph does not intersect this line. It only intersects at this one point. So let's look at what this looks like. So it turns out that our function gets really close here. It intersects this point, goes up, and then immediately down again pretty much, and it never intersects our axis. On this side, it's very similar. But it doesn't intersect at all over here. Notice we didn't have any zeros, so it's really close to these asymptotes here. And then in this tiny spot up here, looks like we've got something that looks very similar to a parabola up here. And so this huge gap right here, there are no y values. No y values in this kind of chunk up here. If you want a better idea of what this graph looks like, this is a more precise version. Notice that we've got our parabola up here between -1 and 0, and we've got our asymptote on the left-hand side of our function. It never touches the x-axis, and on the right-hand side, if we like zoom in, we can see that it intersects at 2. It goes up, and then it starts to come back down again. And then now our x-axis is the asymptote again. All right, so last example. All right, so we've got this function here. We need to factor out. The only common factor in the numerator would be x, and then we've got 3x plus 1, and in the denominator we've got a difference of 2 squares, so we have x plus 3, x minus 3. Alright, so no common factors again, so there are no holes. Looking at We need to look at our vertical asymptotes. So we're looking at our denominator. So we've got x plus 3 equals 0, x minus 3 equals 0. So we have vertical asymptotes at x equals negative 3 and x equals positive 3. So a little bit more spaced out this time. Next, looking at our zeros. It's where our numerator equals 0, so we're looking at x equals 0 and 3x plus 1 equals 0. So we've got them really close together. We've got x equals negative 1/3 and x equals 0. So between negative 1/3, which is, say, right here, and 0, our graph kind of comes up and then down again. So it intersects at those two locations. And then, all right, so finally, we're looking at our horizontal asymptotes, which is, we want to look at the degree here. The degree of the top and the degree of the bottom, they're equal to each other, which means our asymptote, a horizontal asymptote, is the line y equals the leading coefficient of the numerator over the leading coefficient of the denominator, which the denominator is 1. So we've got at 3 over 1, which is the line y equals 3. So here. All right, so we've got our zeros, our asymptotes marked. So now it's just kind of time to sketch the graph. It turns out we've got like it's kind of upside down parabola here. Oh my god, that looks awful. But that's why I have my graphing program. And then over here it goes like that, and then over here it's kind of similar. Oh, I wasn't supposed to touch that line. But our graph looks very much like this. If you want to see a more professional version of it, it looks like this. So notice it touches the x-axis at only those two spots that are really close together. And then this gap between here, they're basically, these y values are not part of the range. So that is it.